Hi everyone, in this video we are going to be covering evaluating expressions and factoring. Okay, so let's talk about evaluating expressions. We'll talk about what does that mean, what does it look like, how do we do it. All right, so you will frequently see the phrase evaluate the expression used in math relative to algebra. Right, so evaluating an expression means to find the value of the expression when the variable is replaced by a given number. Okay, so let's focus in on our keywords here. The variable is replaced by a given number. All right, so the variable is being replaced by a given number. Now, what does variable mean? What do you think a variable is? What does variable, the word variable, mean? So variables, think of like if someone asks you a question like, oh, what's the weather like where you live? And you might say, oh, well, it varies. So variable comes from that same word. A variable is a letter that represents an unknown value. All right, so our job most of the time is to find out what is that unknown value, to solve for that variable. All right, so here's an example of an expression. Now, you cannot use the words expression and equation interchangeably. An expression in algebra, an expression is not the same as an equation. We'll talk more about that in a minute. But this is an expression. If there's no equal sign, it's an expression. If there's an equal sign, it's an equation. All right, so here, what is our variable in this expression? 6x plus 2. Right, the variable is x. Right, so x is our variable. In this particular expression, 6 would be called the coefficient of our variable. 6 would be called the coefficient. So 6 is the coefficient. Coefficient is just the number in front of a variable. That says CI. That my handwriting was kind of sloppy there, sorry. CI. There we go. Okay, so 6 is our coefficient. X is our variable. Our operation here is addition, so that plus is indicating the operation. And 2 is just a constant. All right, so we call 2 a constant. So that's where you have a number without a variable, a number that is not attached to a variable. All right, so you see the 6 is attached to the variable, so it's called the coefficient. The number that is not attached to a variable is called the constant. All right, so let's do a little example. Evaluate the expression at x equals -5. We're using that same expression from the last slide. The directions here, evaluate, that means to plug in. So to evaluate means to find the value of that expression at the when you plug in the variable. All right, so evaluate the expression at x equals -5. All right, so we're going to replace x with -5. All right, so that's going to become 6. So right now we have 6 times x plus 2. Okay, so 6 times x, here x is becoming -5, plus 2. All right, so I've got the equal to there just to indicate that those, that this came from the previous line. Here they told me that x is equal to -5, so these two expressions are the same. All right, so now I'm just going to use my order of operations, GEMS or PEMDAS, whichever one you prefer. So remember, GEMS and PEMDAS, that's our order of operations. The G in GEMS tells us to do grouping operations first, like parentheses, brackets, absolute values. Then we do exponents, and then multiplication and division left to right, and then subtraction and addition left to right. All right, same with PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. All right, so here we have multiplication that we need to do first. 6 times -5 is -30, plus 2 just drops down. And then -30 plus 2 would be -28. All right, so that is the value of the expression when x is equal to -5. All right, so easy enough. All right, so let's talk a little bit more about expressions versus equations. Expressions are combinations of numbers, variables, and operation symbols. We just saw that on that last slide. We saw that expression 6x plus 2. So we've got a combination of numbers like 6 and 2, variables like x, and then operation symbols like addition. Equations are made up of two expressions connected by an equal sign. Right, so an equation is where you take that expression and set it equal to another number or another expression. All right, and then one last thing, and then we'll get started with some examples. You may also be asked to solve an equation for a particular variable. Right, so I'm sure you've all seen those directions before, solve for x. And whenever you're asked to solve an equation for a particular variable, what they're really asking you to do is to isolate that variable on one side of the equation and put everything else on the other side of the equation. Okay. All right, so let's get into some examples with expressions and equations and variables. All right, so starting off easy, solve for x. We have 6x plus 2 equals 14. What do y'all think we should do first if we're trying to get x by itself? We're trying to isolate x. The first thing that's standing in our way is this plus 2. All right, so let's move that over first. All right, so we're trying to solve for x, so let's move the 2 over, subtract 2 from both sides. It's going to cancel on the left. All right, so we're left with 6x on the left equals 12 on the right. All right, we're trying to solve for x, so divide both sides by 6 to get x by itself. All right, so we're trying to get rid of this 6, so we're going to divide, because right now we're multiplying by 6, so we can divide to get rid of it. All right, so divide both sides by 6, the 6's cancel, so you're left with x equals 2. All right, so x is isolated, it's by itself, everything else is on the other side of the equation, and so you have solved for x. All right, so here we have a little evaluate the expression problem. All right, so evaluate the following expression for x equals 2, y equals 6, and z equals -3. All right, so let's look at our expression. We have 5x plus negative, and then in parentheses, -2 plus z, close parentheses, minus 9y. All right, so let's start plugging stuff in. So we have 5 times x, right? What was x supposed to be? X was 2, right? So replace that x with 2. So 5 times 2. Right, moving right along. Next we have z. We need to plug in -3 for z. All right, so we're going to plug in -3 for z. So we have plus, parentheses, -2 plus -3, close parentheses. All right, then we have minus 9 times y. Y was 6. All right, so let's plug in 6 for y. So that's minus 9 times 6. All right, cool. So now we've just got to do order of operations. All right, so we're going to do inside the parentheses first, or inside the grouping symbol. -2 plus -3 is -5. All right, now I'm going to do my multiplication. All right, so 5 times 2 is 10. I'm just going to drop that down. So plus a negative 5 becomes a minus 5. And then negative 9 times 6 is negative 54. All right, now I'm going to do my subtraction. That's all I have left. I'm going to do my subtraction just left to right. 10 minus 5 is 5, and 5 minus 54 is negative 49. All right, so that is the value of the expression when x is 2, y is 6, and z is negative 3. All right, next we have a very similar problem. Evaluate the following expression for x equals 3, y equals negative 4, and z equals 12. So new values for our variables. And the expression is 7z minus 5y times 2x. All right, so I want you to try this one. So pause the video, plug in the values, and come back and make sure you get the right answer. Okay, so hopefully you have had time to pause the video and try this yourself. All right, so we're plugging in, let's see, 7 times z, so that's 7 times 12, minus 5 times negative 4, times 2 times 3. All right. 7 times 12 minus 5 times negative 4 times 2 times 3. All right, so let's do our order of operations. We've got to do our multiplication and division first. Here we just have multiplication. So we're going to do it left to right. So 7 times 12 is 84. And then we have 5. So let's just keep track of that up here. Let me switch this and say, okay, that's going to be 84. And now looking at the right-hand side of my expression here, well, let's just do 5 times negative 4, that's negative 20, times 2 is negative 40, times 3 is negative 120. Okay. So 84 minus negative 120. Double negative becomes a positive. Add those together, that becomes 204. All right, so hopefully you got that. Just be careful with the operations. Make sure you're using order of operations. Don't rush through these. Take your time. All right, here we have one that is a little bit more difficult. I say that because it's in a fraction. It's really not. It's really not that much more difficult. It's just maybe more intimidating because it's in the form of a fraction. It says evaluate the following expression for k equals 7, m equals 0, and p equals negative 9. So here I was just picking some random letters just to show you that it doesn't have to be x, y, z or a, b, c. It can be any letters. Anytime you see 0, you want to think like, oh yeah, that's going to make this easy, because if you're multiplying by 0, it's going to cancel it out. If you're adding 0, nothing happens. So you love to see that 0 in there. All right, so here's our expression. It's a fraction. It says negative 8m plus 2k in the numerator divided by 6p minus 4k times 5m. All right, so let's plug in our values. M was 0, k is 7. All right, so m is 0, k is 7. All right, so I've got those plugged in. And then in the denominator, p is negative 9. Excuse me. K is 7, m is 0. So that's going to be 6 times negative 9 minus 4 times 7 times 5 times 0. All right, so now we can do order of operations. We need to simplify the numerator and simplify the denominator separately. So when you're thinking of this, think like, okay, I'm going to start by working up here, and I'm going to simplify that. Then once I've got that simplified, I'm going to go down to the denominator, and I'm going to simplify it. Then once I've got both of those simplified, then I can think of it as a fraction. Right, so just think of it as two separate pieces until you get the tops and bottoms simplified. All right, so negative 8 times 0, that's going to cancel out, right? Negative 8 times 0 is 0. So that cancels out. And then down in the bottom down here, we've got 4 times 7 times 5 times 0. All right, so 4 times 7 is 28. 28 times 5, what is that? That's 140 times 0 makes it 0, so that cancels out as well. All right, so lots of stuff canceling. So let's see what's left. 2 times 7 in the top and 6 times -9 in the bottom. All right, so 2 times 7 is 14. 6 times -9 is -54. But now we need to simplify this. The directions did not say to simplify, so I'll try to be more specific when I put this on the little assessment piece. But you do want to simplify these. 14 over -54, you can just plug that in your calculator and have it simplify it for you, but you could also just notice that 2 goes into both of these. 2 goes into 14 7 times, 2 goes into -54 -27 times. All right, so that's 7 over -27. All right. Now we've got a little bit, this one's actually very similar to the solve the equation that we did, that solve the equation example we did earlier. But this one says solve the equation for k, so different variable, and it's 9k minus 6 equals 48. All right, so what do you think we should do first? So I want you to try this one. It's very similar to the one we did earlier, so you can take a look at that one if you need some direction. All right, so the first thing you're going to want to do is add 6 to both sides. That's going to give you 9k equals 54. And then if you divide both sides by 9, it gives you k equals 6. Right, so that becomes 9k equals 54. Divide both sides by 9, and that gives you k equals 6. All right, little bit of a different style question here. It says solve the equation for t, and we've got all variables. All right, so don't let that intimidate you. We're treating these variables just like they're numbers. That's what they are. They're just representing an unknown value. All right, so we're trying to get t by itself. All right, t is down in the denominator right now. So we need to get t out of the denominator. What can we do to move this t over to the other side? We can multiply both sides by t, right? That's going to cancel it out over here. So it's going to cancel it out on the right-hand side. It's going to get it out of the denominator. And now we can work on getting t by itself. All right, so we've got t times s equals d. Trying to get t by itself. Remember, we're solving for t. All right, so go ahead and get t by itself by dividing both sides by s. It's going to cancel out on the left. And then t is by itself. And then on the right-hand side, we have d over s. So when you have all variables, nothing different. You just treat them just like they're numbers. All right, slightly more difficult. Solve the equation for F. This is the equation for converting between Celsius and Fahrenheit. So we have C equals 5 over 9 times F minus 32. All right, so F minus 32 inside the parentheses. So right now we're trying to solve for F. All right, so that's what we're going for. We're trying to get F by itself. The barrier right now is this 5 over 9 in the front. Right, so how do we get rid of 5 over 9? How can we move it to the other side so that we can get F by itself? What could we do to get rid of 5 over 9? Y'all might remember this from, from your last algebra class, but if you want to get rid of a fraction, if you want to move a fraction to the other side, you can multiply both sides by its reciprocal. Right, so you can, let me erase this. Okay, so you can multiply both sides by the reciprocal of that fraction to cancel it out. Right, so I'm going to multiply by 9 over 5, multiply by 9 over 5. Whatever I do to the right-hand side, I've also got to do to the left-hand side. Right, so that's going to make those 9's cancel. So we got a 9 in the top, 9 in the bottom, and then a 5 in the bottom, 5 in the top. So 5's are going to cancel. So 9's cancel and 5's cancel. So we're left with 9 over 5 times c. And then on the right-hand side, we've just got f minus 32. So you see I've dropped the parentheses because I've gotten rid of that fraction out front. And now I'm trying to get f by itself, so the last thing standing in my way is this 32. So I need to add 32 to both sides to get f by itself. That cancels out on the right. And we have f equals 9 over 5c plus 32. And I know some of y'all have told me you prefer to put what you're solving for on the left, so if you write it this way, that is fine. So those two answers are the same. Okay, everybody, that's it for this video. Now I want you to go complete the evaluating expressions hybrid assignment that is in D2L. If you have any questions, please send me an email and let me know.